So these things always happens whenever we deal with the force. Now the first point here we discuss the effects of the force. The force causes motion. The force causes motion. So let us understand this point very deeply. So before that, I am showing in the diagram. So in the diagrams there are certain arrow marks are there. So these arrow marks shows about the direction of the force, and the size of the arrow mark shows about how much bigger they are. Okay. Now I will explain in detail about this right now. Now here you can see here a single person. So he is applying a force on this trolley. So he applied certain force. So his force is along this blue arrow mark direction, along this direction. So here it's mentioned that the applied force is 15 Newton. Yeah, force units are nothing but Newton. I can talk about that. Now here you can see, now he is pushing the cart, and between the wheels on the surface there is a force which always acts on the surface. But that force is nothing but friction force. Now if you can observe it here, now the force applied by him is 15 Newton, and the friction force at here showing as 10 Newton. Now friction force is less than the applied force. Yeah, obviously the cart will be moves. Yeah, here I discuss about force always comes in pairs. So here you can see two forces are there. So this is the applied force. So this is the friction force. Their force always comes in pair, and they both are in opposite direction. Yeah, one is moving along, if you can take, this is the east direction, and one is moving the backward directions as west direction. So that's why force always comes in pair. Now let us understand further. Now here you can see in the diagram, so this is the small amount of the load. But here you can see in the figure B, the load is increased, means the mud in the trolley already increased. The load is increased in the figure B. Now, but he is applying the same amount of the force. He is applying the 15 Newton force in the forward direction. But in the backward direction, you can see because of the load, friction force is increased. So now friction force is 30 Newton. Now friction force is more than the applied force. In this case, the trolley, it won't move. It won't move because friction force is more than the applied force. That's why the trolley, it won't move. So from the third figure, from here to here and from here to there, in the third figure, so to move this trolley, so he took his friend help. Now two persons came at here. So those two persons are the applying force. Now here you can see the applied force is 30 Newton and the backward force is also 30 Newton. So now in this case, the both forces are opposite and equal. So let us guess at here whether the trolley will be moves or not. So that we will understand in the coming classes. But before that, I would like to stress much more about force is always comes in pair. So they are comes in pairs and they are opposite. They are in opposite direction. Now let's see another concept, balanced and unbalanced forces. First, let's define what is the meaning of balanced force. If two forces act on a body in opposite direction, so these two words are important. If two forces act on a body in opposite direction, and if both our forces are equal, then the resultant means the final force, actually on the body is 0. Now, if you can see in the previous example, now in this third figure, if you can closely observe that, now here the applied force is 13 Newton and the friction force is also 13 Newton. Now in this case, what is the resultant force? The resultant force equal to 0 Newton. Now the forward force is exactly equal to backward force. So we can take this case an example for balanced force. So now that figure we can say that is an example of balanced force. Now this we can say that balanced force. Now opposite to the balanced force, which is known as unbalanced force. Now here you can see either this figure you can take, now here you can see, take this first figure. Now the forward force is 15 Newton and the backward force is 10 Newton. Now in this case, the forward force is more than the backward force. Now in this case, what do you think? So are they both are equal? No, they are not equal. So we can say this force as unbalanced force. So in the second figure also, if you can take the same, the forward force is just 15 Newton. Now here the backward force is 13 Newton. Now here the resultant force is, resultant force is there, means which is the leftover. If you can subtract 30 minus 15, so you will get the 15 Newton. So that will be resultant force. Now that force in the backward direction. Now this is an example for unbalanced force. So likely here we define what is balanced force and what is unbalanced force. So we define balanced force as if two forces, so in this diagram, F1 is a force in the backward direction and F2 is a force in the forward direction, and these two forces are equal. So here you can see the length of the arrow mark, the size of the arrow mark, they both are equal and the arrow marks are showing in the opposite direction. So in this case we can say the forces both are equal, so we can say these forces are known as balanced forces. Now balanced forces cannot change the state of rest or motion of the object. So if the forces are the balance, so that force do not change the state of the object. It means if the object is already at rest, then the forces are the balance, then the object it won't move. Or if object is already in motion, then if the forces are balanced, then object it won't stop. So finally, the balanced force cannot change the state of motion of the object. Let's see about unbalanced forces. If you can see the below figure, unbalanced force, the word meaning itself says. Now here we can see the forward force F2, the arrow marks is looks smaller than the F1. Now, as per I said, the length of the arrow mark shows about the amount of the force. Now, in this case, F1 is greater than F2. It means the backward force is more than the forward force. Now, this force we'll say that this force is as unbalanced force. Now, when the force is unbalanced, now in which direction the object moves? So, where the force is more, in that direction object moves. Or simple, we can say unbalanced force changes the state of rest or motion of the object. It means to make object to move, you need to apply force, and that force should be unbalanced force. Let's see one small stimulation to understand the balanced forces and unbalanced forces. Yeah, with the help of stimulation, let's play a tug of war. So here, two teams are present. One is blue team, another one is red team. So each team having 4 persons, and you can see they are different in size. So obviously they are different in strength. Suppose if I take from the blue side this person, and he can apply force alone in this direction. So he will pull the rope in this direction. Now here the arrow mark shows about that what is the amount of the force he can apply in this direction. And similarly, if you can take from this side, so I will take this person and I will take this person. First I will take one person. Now here you can see, now this red person can apply force only 15 Newton. But the blue person can apply force 10 Newton. Now the above arrow mark at here, so this will shows the resultant force. And if you can subtract this 100 Newton minus 50 Newton, so we can get 50 Newton. And this 50 Newton force is in which direction? Yeah, this is in my left direction. Suppose if I hit this go button, so they will apply force on together. Now here you can see in which direction the cart is moving. The cart is moving in my left direction. Why? Because the cart is moving in my left direction? Because on my left direction, what is more? The resultant force is more. Now in this case, the force is unbalanced. This unbalanced force causes the cart to move. It is in motion. Before cart was at rest, now the cart is in motion and it is also moving certain speed. So unbalanced force causes the object to move or at rest. Now let me take one more example for the balanced force. Now this time I will take full team. So I will take on the left side full team and I will take on the right side full team. Now here you can see at here on the left team means blue team will apply force around 350 Newton. They all together apply force 350 Newton. And the red team also, they apply same amount of the force on the right side direction. So this is the 350 Newton they will apply in the right direction. One will be applying the same force and another will also apply in the same force in the right direction. Now what is the resultant force? If they both are applying the same force in the opposite direction, there will be no resultant force. Suppose if I make them to go, so if I hit go, now the both teams are applying force. So they are applying the strength. They are applying equal force on both sides. See, here you can see it is the 350 Newton and 350 Newtons. Now in this case, is this cart is in motion or rest? It is already at a state of rest. Now it's already at rest. Now it will be in rest. Why? Because even the force is applying on the cart, but that force here is a balanced force. So if balanced force acts on a rest object, then the object will be at rest. And the object will not change. It will not change its state. That's the correct word here you have to mention. The balanced force, it won't change the state of the object. Now here you can continue here forever. So if you can do it this forever, so then they will be like that. But the cart, it won't move at all. Suppose now if I take one fellow down, now I will pull this fellow down. Now here you can see what happens. Now it became unbalanced force. Now it became unbalanced force. Now in this unbalanced force, you can see in which direction more force is there. So on my left side, more force is there. So the right side force became less. Why? Because I pulled one person out of the team. So obviously the left side force is more. The cart will be the most on the left side because the force here is unbalanced force. So this is all about balanced and unbalanced force.